Hello and welcome. I'm Bill Wake. We're here working on a program to assess the similarity of different tunes, and we've come a fair ways. We've got something that generates what's called the Parsons code, which is sort of the direction of the melody over time, and we're looking at things to do. We'd like to do that with different time signatures and take into account the lengths of the notes. We've had an approach that worked. Let's start here. So the way we were, 24 hours ago, maybe, maybe a little longer, was we had this input stream. We get something that says L:1/8 that says by default notes should be eighth notes. And so when you see A, B, C, D, E, F there, let me take out that. There's an extra 2. I had a crash of Keynote, just like randomly stopped. All right. So L:1/8 and A, B, 2, C says that should be an eighth note, 2 eighth notes, which is a quarter note and an eighth note. And you can see the first 3 notes down there is eighth, quarter, eighth. And then we switch to L:1/4 and D, E, F are all quarter notes. All right. And the way we're doing it is we originally could handle the first one in the tune header, and then we support the second one because we're doing line by line, and we just say, okay, there's a standard note length, use that. Okay, it's 1/8. Then at some point we see that L:1/4 line, we say, oh, now the standard note length is a quarter, use that. And we go on and continue parsing with that. The problem is you don't have to put these on standalone lines. There's also a form that's bracketed. So we have A, B, 2, C again, and D, and we switch the 1/4 note after the D. Oh, I can see all right. And so that means A should be a eighth note, B2 should be a quarter, C should be an eighth, D should be an eighth, and E and F should be quarters. But we don't work with that. The problem is this L:1/4, when we do it line by line, because of the way we're parsing, we parse lines individually, and it's okay that we're carrying state across. But with the state changing in the middle, and our parser is able to do backtracking because there's some modest ambiguities in the grammar. Well, potential anyway. I mean, I'm not sure you couldn't get around them, but in a simple view, they're definitely there. So we're using this the parser that can backtrack, and if you're changing state in the middle and backtracking, it gets confusing. It's just not the way it's designed to operate. It's designed to say, you gave me some stuff, I can build it into a component for you. I mean, I can assemble it into something for you like a note, but if I need to throw it away, I just throw it away and we don't worry about it. And this L:1/4 in the middle says, no, I want you to start worrying about, these notes should be interpreted differently and so on. Now, I feel like, I haven't proved it out, but I feel like there's probably a way to say, okay, well, that length of the note, we're going to carry that forward as part of the objects that are getting built. And so you won't just build a note, but you'll also build the note duration table or something, some sort of structure state. Tune state is what I called it before, but you're going to build that state as well as the notes, and then interpret the notes in terms of the state. And if the state changes, you carry it forward like that and so on. And if it backs up, you just throw that all away. I'm sure that could be done. I don't know if I want to take the time to try it. Maybe I should, I don't know. But that's my one alternative, is to say, okay, well, we'll complicate every piece of analysis to say you might have to worry about state. Okay. So the AB2C, they would also have to worry about like, oh, what's the current state at this moment, and make sure they deal with that and so on. I think what we're going to do instead is my second alternative. I don't have 3 yet, so it's more of a dilemma. I guess that makes it. Instead, what we're going to do is we're going to capture the information, kind of like treat the notes coming in as sort of an event stream. And I'm making up some notation, but I'm going to say like, hey, there's something that says these are eighth notes. And then there's something that's duration 1, implied, A, and then something that's duration 2, the B, and then another thing that's duration 1, another one that's a 1, C and D, and then, oh, we're going to switch to quarter notes. That's the next event. And then it's a 1, even though it's the one just before it was an eighth note, is going to be an eighth note. This one's going to be a quarter note, but we're not interpreting yet. We're just saying, as far as I know, it says E by itself, no numbers, so it's a 1. And F is a 1. And then we'll run a phase at the end to do the analysis and convert it. So convert that stream into the set of note values that we expect. And so what I'm thinking of these as the ones on top, the 1, 2, 1, 1, 1, 1, that is more like relative note durations. So I don't know if it's an eighth note or a quarter note when I see that 2 in the middle there. I can only know that if I've worked my way through the stream and said, oh, I see, I'm still in eighth notes. So in effect, the numbers, not the fractions, but the whole numbers are the relative durations as listed in the input. And then the fractions are sort of the event markers that say switch your interpretation. And so we're going to have to do the interpretation at the end. We sort of do this already for measures. You could have bar lines that separate these things into measures, and we don't try and interpret that as we go. We just do that at the end. So I'm going to do the same. I'm going to augment the measure stuff with note duration calculations. Okay. And this is a bit of a backtrack. I mean, before we were fine with this, but that scheme just isn't going to work the way we are when we make it a little more complicated. So the 2-level parser that parses lines as a whole and then parses within lines, that scheme just doesn't work for carrying state through within a line. Okay. And so we are doing a small bit of backtracking. Not zero. I mean, it's a noticeable thing. All right. So with that, all right. So what we want to do is we want to apply L, the note durations, when we calculate measures. Now there's an ambiguity in what we have. Should L in the tune header or a top level body become an event? And I think the answer is yes. I don't know about the header, but the body for sure. Okay, so let's go back here. This one now, I want it to act the same as this interior one. Okay, and so I think the way it is now, it just updates the state and then continues. We're gonna turn it into an event. Now, it's like memory here. I think we apply L in the middle the way we are now. Yeah, we do, because we added a musical element. See, I may have to pull that class out. We added a unit note length change, okay, and that was that rhythm. So when you parse the body, let's see, ABC parser, down here somewhere. Okay, line starts with L. Well, here's the header, but then here's the body. If line starts with L, we're not going to worry about the assignment. Try the unit length parser and produce tune state. Okay. That's, well, I guess we have to go to unit note length parser. Okay, let's go there. Unit note length parser. Okay. And the result of its parse, well, the true result is this parser. This parser, when you call it, it returns a rhythm. Well, that's still not quite what I'm thinking. I mean, that's fine. It returns the rhythm. We need to be returning a note length, though. Let's find ABC score again. Let's see who references this. Oh, note length line parser. Okay, yeah. So it matches that inline field, calls the unit length parser, gets the rhythm from it, and turns it into a musical element. Okay. I'm good. All right. So I think what we need to do, maybe the first thing is make this one. let's phrase it as a positive action. Make L in tune at top level tune body generate an event. I don't know, event's not quite the right phrase, but I probably should use the word I use here. Well, element is probably a better word. A musical element. Okay, so we do it inside the line because the unit parser does that, but we really should do that at that level. Okay, and I'm not quite sure. The other thing I'm not happy is I think our tests, they don't really operate well. We've made them check that we do the relative note durations, but we don't have anything that checks the absolute durations. We don't generate them yet. I think we probably should have those tests. Sorry, the parser. But we don't. So I think what I want to do is make sure that the unit length parser generates that. Okay, so add notes is really not notes. Let's see. I believe add notes is going to add elements. No, it adds a score. Tunes.last. What is tunes? Okay, so the tunes.last thing says we're keeping a list of tunes, add it to the last tune. Okay. I'm going to make this add score. Maybe it's just add. I don't know. Append tune. I don't know. Instead of append tune. Okay, that's a bit different. Yeah. Okay, so, well, what I want to see is when you finish parsing this thing, it ought to have generated an event or an element. All right, and let's see where this happens now. So we want a unit note length right after title. Okay, that's a header. In tune header. Unit note length in body. Okay, so here we've set up one in the header. We've set up one in the body. Notice we're checking the notes G2, G3, but we don't expect an element for this one. I think this is the one that needs to change. All right, and it's going to be like this one. It's going to want to see the element with the note length change. Yeah, that feels like the right approach. The header one, I'm not so sure. It could be we decide it should generate a header element. Oh, hey, Viv1377, welcome back. Okay, so what I want to do then is I want to say the ones that come on their own line should really act just like the ones that happen in the middle of the line. Okay, and so I almost can. Let's just take this. Okay, so this is element 1 is that, and element 2 is this. Okay, and there may be another test somewhere that checks this a little. I don't know. There may be more than one place we need to change, but this is the one I definitely see. So run this, it should break. Oh, I should run all the tests and make sure everything other than this one passes, but I'm pretty sure we left it that way. Okay, I won't worry about that. Usually I try and start this once, but run it once and get it warmed up. Okay, yeah, so that blows up. Good. Let's ignore this one for a moment and run all the tests. Other tests. Okay. Good. So this is our failing test, and we're going to modify our code to take that into account. Well, I think we talked about this in the intro. So here's ABC parser up here in the tune body. If you get an L, then we try and parse it, and we generate tune state. See what we're doing there. Unit note length parser. Okay. So we have this parser that we built. We called make in the constructor down here. So the parser is it reads that L colon 1/8 and generates the 1/8 basically. All right, as a rhythm. Okay. And then we have this helper that we're using here. It's not the parser. I mean, it uses this parser, but it's using a helper method for it. So it generates the rhythm. Okay. And then it updates tune state with it and returns in tune header. I don't particularly like that. I almost think we want to do this. Let's kind of inline this. Where's ABC? Okay. Down here. Okay, so this is parsing it in the tune header. And actually, it's both these. If you're looking for titles or you're looking for this. So if I inline this, I'm really doing this. State equals. Okay. And this goes away. So I inline that method. I don't know if anybody else was calling it. Okay, but this is unit note length parser. That thing's parser. And the line. Okay. All right. This should run the same. Well, this should fail. Let's ignore our test again. Where was that? ABC. Yeah. Put this over here. Okay. Let's ignore this one and run the others. And I'm just trying to be very stepwise careful here. These should all pass. Okay. And now I'll take this back out and modify that. Okay, so ABC parser. Put you right next to it. Good. Okay, so we got this rhythm. We stored in the tune state, but really we need to append it to the current tune. Okay, like the notes do, wherever they are. Tune header, tune body. Yeah, tune body. Okay, so the notes, they run parse it, note line parser. Let's see what that thing produces. Okay, it produces a score. I don't know if I like that. Okay, maybe we're doing too much there, but okay. So anyway, what I want to do, and I have to repeat this work, unfortunately, but I'm saying what I should do is just like the tune body. Wait, sorry, I'm getting myself confused. gather titles is not where we want to do this. Okay. Okay, that's where we were. We're just doing this in the body. I think we may do this in the header eventually, but it should be just in the tune body. Okay, so now if I import this again down here, well, I did underscore equals, so I'm not screwing around with the tune state. Okay, it's the state machine that decides if you're in the header or body or whatever. Okay, so this is this dot parser. I'm going to comment this out. All right. And so I got rid of that line that's not doing anything. I changed this, but now I don't think I care about tune state at this point. I don't care about tune state note length. We're not doing anything with it as we go. What I want to do though is I want to generate a musical event. Well, let's do it. Musical event element dot unit note length change to rhythm. Okay. Let's say let element equals that. Okay, so we're going to take that rhythm that the parser found, and we're going to say, okay, let's wrap it up as a musical element so that we can stick it in the note stream. And then I'm going to do that. I'm going to have to, well, here I do tunes.add notes. I need to do something like that. I'm going to say tunes.add element, and we'll have to fill that in. Tunes.add element. All right, and I think we'll inline that when we get it done. Okay, there is no add element. Actually, let's just append. Okay, and we have element, but we don't have, well, we called it add elsewhere. Okay, let's try it this way. Append. All right, now tunes has no method append that takes an element. It really has these add notes. Okay, and maybe I should just conform to that for now. Let me do that. I'm gonna call it add, and we'll let it straighten itself out on whether it's, we'll let the type deal with that. Okay, so I'm saying there should be a function add. I wish there were. That's public function add that takes an element of a musical element, and well, it must be something with tunes.last dot. Oh, interesting. I don't get a suggestion. Well, tunes is talking about tune. Okay, so let's go to tune, see what it has. I'm hoping it has some sort of add. Add title, add key, add notes. Well, it doesn't really have an add element. Okay, let's add one, because I think it owns elements, right? Oh, well, it owns a score. Parts, yeah, it owns scores. Okay, let's see what we can do to score. And I don't know, passing this thing on and on and on is really annoying. Okay, well, score is a list of musical elements. So that's the guy we want to get to and add that too. So I think I'm just going to push it through. I don't know. It's making this a big step, and I don't like big steps. All right, so tunes wants to say last dot add element. Okay, now there is no add on tune. Okay, so let's go add it. Tune, I want to add, I want a function add, which adds an element, musical element, and self.currentPart.add element. Okay, now we have score does not have add. We should get it in a minute. Okay. Cannot convert element to expected type score. Yeah, so let's go to there. All right, here we are in score, and we would like to add an element of musical element. Okay, and that's self.elements.append a new element. Okay, so we pushed it in a few levels, and I think there's more work to do in there, but let's see how it's doing. All right, so I believe this should build, and if it builds, I think it should run. Oh, still don't have. It's like it's not building. Let's do a. Oh, there it goes. Okay, build again. All right, that's apparently happy enough. Let's run our test, and I think that should pass now. Because ABC parser in the body adjusts when it finds an L, it appends a musical element to it. Okay, so I don't need this line anymore because it's commented out, and I'm doing that. I don't think I need this tune state anymore either, because we've totally pushed it to the event stream, the element stream. All right, so that should not change anything to take that out. Okay, and we said we'd inline this musical element, and I think we can probably just drop the musical element because it should know that the type has to be that. Okay, so if I do that. Good. Okay, so make L colon as a line in the tune body. Put an element, a unit change element, unit note change element into the current score. All right. Now, doing that makes me feel like there's, I don't know, there's things going on here I'm not liking too much. And I don't know. One thing is we have this two-level parsing that's the lines are parsed separately, and that's nice in a way when you're pushing this stuff through, but when you have these inline ones that you can't push through that way, it sort of starts making two classes of things that, you know, they want to be similar but they can't. The other thing, well, let's go to tunes. No, tune. The other thing is the tune, we're doing something very similar for parts. So tunes can have like an A part and a B part, and you can tell it somewhere like, hey, do A, B, B. Okay, so play the first part twice and then play the second part twice. The way we're doing it now is you can put the parts as line things in your music, and then we divide it up as you go. Oh, I saw that this should be in the A part. Okay, so accumulate A parts. They mark it B, and we say, oh, now you're going to accumulate B parts. Okay, the current part is B, and we accumulate those. But the problem is the part stuff can also be inline. All right, let's go to our spec here. And, you know, I mean, I complain about specs, but everybody who uses specs probably complains about specs. But here, this one says, hey, P can be inline. Okay, which means I can do it as I go. And I think even in their examples, I think they do it once. So they gave us some examples of their tune. I don't see any parts on this one. This one does. Okay, yeah, they've used the inline part marker. They could have put this on a separate line by itself, but they didn't. And then I think there might be one that uses it in the middle. of a line. Maybe not. Okay. Yeah, that one's a little too weird. It's a multi-line thing that doesn't fit what I'm trying to do mostly. All right, but in any case, you can put them in there like this example did, inlined, and now we have the same problem. You can't accumulate inline stuff. The stuff within a line can't accumulate state across the lines, basically, or even within the line. But we're not ready to deal with it. So even this, we don't support inline parts, but our approach doesn't really work if we did. So I think we've got a fair bit of work to do. And I want to push forward on stuff and get the next feature. But this is the kind of thing that you see it when they talk about technical debt. This is kind of what I think Word meant. Not just I wrote some bad code and I should fix it, but code that served its purpose before when we only had part markers that took a whole line now does not serve its purpose. We know that. We have a restriction that says don't try and do this inline, and we know that needs to be upgraded to a more sophisticated model, and yet we haven't done it. Okay. I don't know whether to be insulted or flattered, but okay. All right. So let's slide this back a little. It always jumps over when I commit. All right. So when we finish bottom line is when we finish this thing for the note lengths, we're going to have to come back and do it for parts. And also we can see everything else in that table, key signatures and so on. Just about all of them said yes for inline. Not every single one, but a lot of them. And so we'll need to do those as well. So all the ones that say inline, they have the same problem we're dealing with here. Most of them we haven't touched. Some of them we won't need to. I don't need to worry about lyrics, for example. Okay, so let's see. So if we look at this top level body generated musical element, okay, we've done that. All right. Apply L when we calculate measures. Make sure existing tests check after that calculation. Well, we know they don't, but we need to write tests that are similar that do. Should L in the tune header or top level body become an event? I guess the question now, we did top level body, so it's this one. Okay. And apply L when we calculate measures. I think that would be good to do now. So we do have to calculate measures on tunes. Where's tune? Nope. Okay, I think tune has identify measures. Yeah. So let's see. We want to find if this is where this is being used. Okay, mostly tests. Actually, only tests. Okay, so that's kind of the top level for now. We know we need to do it, but we are only doing it in tests right now. Okay, and sorry, one more thing on, well, a couple of refactorings, I guess. One is score is the easy one because I know we want to pull musical elements to its own file. Okay, it's just growing and going to get bigger. Okay, musical element. All right, and we'll save that, and I think we'll clean build filter, get a clean and a build. And that should be neutral to our tests. 0.09 seconds seems longer. All right, but good. We'll extract file from MusicalElement. All right, the other thing that came up while we were looking, oh, ABC parser. Yeah, I want that unit length parser. Okay, my question is, does anybody use this function now? I think they do. I think the header ones do. Unit length parser. Yeah, that's in the header. Okay. All right. The thing I don't like, I thought I liked that state thing. I don't think I like it. So I'm going to pull that part out of the unit parser and put it in where we do it, apply it. So I'm going to make it, it's not going to return a parse state anymore. Okay. And so these two places. All right. So we can't do that. We got to do state equals, whoops. That and here. So I could have inlined the whole thing and then re-extracted it, but I'm just kind of doing this little limited one. All right. And then do these things. Okay, I don't care about a new state anymore, so I'm just going to try this. Take off the new state. The note should be a rhythm of 1/1, yes. The tune state note length. I don't know if I care about that either. Okay, so new state goes away. Okay, I think these should be good. All right, so remove state calculation from the parser. And I think a reason for that is they really are two separate things, and I think they're different contexts want them different. So we don't want to just ignore it, I guess. If it's not something we care about, we shouldn't even have to talk about it, I guess. All right, let's go back to ABC parser. Our L line, okay, that's in the header. Let's look at the one in the body. Oh, we get the rhythm. Oh, we don't call that parse it method anymore. Okay, so I think, yeah, we're only calling it up here. Parse it this. Let's look at that again. I think as we pull stuff out, there's less and less point to having this method. Yeah, I think we can get rid of it. Parser. Okay, so I'm inlining this to the gather titles section. Okay, so rhythm equals that. Tune state, this goes away. And this is unit note length parser. Okay. And then L here. Same thing. UnitNoteLengthParser.parse. Line, rhythm, this line goes away. And that, okay, that should be the same. All right, and now I don't think anybody's calling UnitNoteLengthParser. Maybe the tests are directly, but we can make them. Oh, it's like it didn't really try. Okay, let's run that again. Okay, find usages. Okay, that's wrong. It's not there. It's not there. It's there. These don't. Okay, they would need to inline that. All right, but I think that's actually a good thing for them too. Okay, so this parser.parse, we're going to say rhythm equals that. We don't need to look at the tune state now. We're just going to look at the rhythm. Okay, so this parser, we're making sure it... Oh, I'm going to diff that. I think the line was L:1. Yeah. Okay. Right, and we don't need tune state. Yeah, that simplifies things. Okay, so we take the unit note length parser. I'm going to inline this too. Take that out. Okay. So try the parser on L1. It should get back a rhythm 1-1. Yes, that's actually pretty good. And that pushes our parser much more towards what it wants to be. All right, this one has got some spaces. Let's space this out. Okay. One 16th, we don't need tune state, we don't need this, and we don't need that. We just want to get the rhythm. Okay, that's definitely going in a good direction. Okay. Try parser.parse L:1/3. Oh, we want parse it. Paste this and then straighten it out. Okay, we're going to try parse it. We don't really care about the return result because it's going away anyway. It's not going to return anything. And we need L:1/3 in here instead of this. Okay, so we're going to try our parse it. It should throw an exception because it's got to be a power of 2. And we pull back, find the message, and make sure it says it must be a power of 2. Okay, we don't need tune state anymore. All right, that should be good. Okay, and then nobody should be calling this. They're not. Okay, so this function goes away. All right. I think that's good. There may be a way to do even more for it, but this seems like progress. Okay, so we've eliminate parse method from UnitNoteLengthParser, adjust colors and tests. All right. Now, okay, tune state is totally out of this thing. That's good. All right, should not be involved. All right. I think we're done with these two. Parser was never used. Oh, we inlined it. Okay. Make sure that's okay. All right. Okay, so we did some refactoring there. We move MusicalElement to its own file, and we inlined UnitNoteLengthParser.parse. Simplified resulting code. Okay. Apply L when we calculate measures. Yeah, so that's the core of what we have to do now to make this thing come back to what it's supposed to be doing. And then we got to find our existing tests and make sure we check them that they're producing absolute notes, not relative notes. Okay. All right. Okay, so that was in tune. So identify measures, I think, is not the best name. I mean, that's what's going on here. But I think I want to call this something like, what's it doing? It's kind of like finalizing, or it's kind of like completing construction, maybe. Let's try complete. Whoops. Rename. All right, and then in here, I don't mind extracting this into a method that's like identify measures. Identify measures. Okay. Right. Okay. So what we're saying we've got to do is, like I mentioned over here, we kind of want to change. We've changed this to produce this in effect, because we haven't done the initial one, but the inline one is now here, and these notes have relative durations. This one's twice as long as that one, but we haven't turned them into actual rhythms like eighth notes or whatever. We just said it will be 1/8 note, but we haven't said it is an eighth note. All right, and so we have to walk through each note, and I don't know if that's done by this. Scores measures. Right. So what this is doing, it's kind of what we have to do, and I don't know if we can do it in one step or two, but it's walking through each note and deciding if it's a note, a rest, a bar line, or a unit note length change. Okay. And when it finds them, it appends well, when it finds the bar, it accumulates these measures. Well, it accumulates these notes, basically notes or rests, into the current measure. So yeah, that's why I have this here. Current rhythm is going to change. We basically run through every element. If it's a measure, if it's a note or a rest, we append it to the current measure. If it's a bar line, we realize we've completed this measure, and let's append the bar line. Append the actual measure into the result. Now, current rhythm is really more like the time signature. The measure is these elements, but notice their rhythm. Their rhythm is kind of whatever they have on there, and it's not right. Yeah, so this, I don't know, it becomes more intricate change, but really this is like, I think what we're saying is the current rhythm is really the current measure time signature. And that's, I don't think that name reflects that very well, because the measure consists of these notes, and the notes all have their own format. So let's go to musical element. Here's a note, and a note knows its rhythm. So it's got its individual rhythm, like 1-1 or 2-1 or whatever. But we need to make that. We need to modify that note to have the actual rhythm, not the relative rhythm. Okay, so I think we can do the implicit ones first, maybe. And this, I think, again, that's got to be kind of like a end of, it's kind of like a completion thing. Measures, we got tests that are looking at them. Let's again. I really want to make. I really want them to call complete, and then measures can just be, this object. Score knows its elements. I just don't know. Okay. I'm going to make this current time signature just to kind of get it into more of a musical term. Maybe even just time signature would be enough to get it. Okay, so the measure knows its time signature. That seems legit. Okay, the problem is these notes, they don't know their, they need to modify by their rhythm. Okay. And the note length change needs to change the time signature. Okay, whoops. Okay, a little glitch there, I guess. Okay. That means let's take score tests. I would like to say when somebody, okay, they got the 4/4, they get the notes. Well, score knows its measures. That's fine. Somewhere I want to say score.complete here. All right. And that says once you've created it, I don't know. I don't know if anybody should be looking at elements. That's the problem. Okay, result is measures, return result. I don't see why we calculate that every time. I think this thing should be aware of that. So I think what I want to say is var measures is, well, array of measure. And it starts out empty. All right, now I don't know if I can name the same thing. Okay. All right, so what I'm trying to do is change this thing to maintain measures outside of itself. And let's call the name the measures for now, just to keep things from interfering with each other. Okay, so I think in this, if I said the measures is empty, well, let's do it this way. Okay, so I'm going to reassign my measures whenever I call this. And then I want to get this thing out of the main path or something. Okay, this should be neutral because it's just a name change. Okay, so refactor, add unused the measures field, updated by the measures method. Okay, now I want to make it so this gets calculated when it needs to. And really it's really these adds that are making the trouble. Okay, so when you ask for measures, I'm going to do this. I'm going to say return. Well, use the word return. I can just say the measures. Okay. If you ask for it, you get that. Public func complete. Okay. Is what you call first. And it's a void. Okay, and the goal of complete is to create the measures. Okay, so let's find the callers of this. Okay, so I've got score with the elements. I'm going to call score.completed, complete. All right, and I need this each time before I access measures. Okay, I'm making progress now. Ooh, except for one slight problem. None is not equal to measure 4. Oh, wait. Tune. Oh. Yeah, that's probably tunes. Oh, that's the test we're working on. Okay. It's just one test though, right? Yeah. Okay. So if you call complete on a tune, we want to make sure the stuff we wanted happens on the score. Okay. So what I want to say is, well, if unit note length changes, then the time signature changes. And this has new time signature. Let new time signature, and we'll say time signature equals new time signature. Okay, that should help a little, but then our measures, our notes get a pass, and I think that's a problem still, so that should still fail. Okay, and all right, so ABCD, these things are quarter notes. Oh, it's interesting. This doesn't even know. Oh, measure 0 in part A should be the measure with the time signature and the notes. Well, I don't know how we get the time signature in there. I don't know that this test is fully together. Okay, so if you say the tune is 4 quarter notes, and that's kind of an implicit thing, and then what are we getting back? We're getting back none. Tune.complete. All right, so what's going wrong here? Let's go to tune.complete. He says identify measures. For each part, run through and calculate the measures in the score. Okay. Oh, he doesn't call complete. Go back. Okay, actually I'll move this up. Okay, to complete the tune, first we mark the score complete, then we identify the measures. Okay. I guess we don't know the score until we're down in here. Run through each part, mark its score complete, and then ask it for its measures. That sounds fair enough. Okay. All right. So we add the notion of tune and score completeness when they calculate measures and time signatures. Okay. I think that puts us ready to write our next test. Let's go back to this one. Okay, a tune knows its measures. Okay. Defaults to an A part, knows its measures. Okay, so this is more about the measures. I think what we need is a test that's like tune handles unit note length changes. Okay, and we need to create the score that's going to do that, and that's going to adjust the rhythms. Right now there's no rhythm adjustment. If we said it was a quarter note, it is a quarter note, but really that should be relative to something else. So we need to make sure it works, and it won't because we don't we adjust the time signature so the measures have the right time signature, but we don't. Actually, that's not even right. Okay. Yeah, we adjust this here, but we don't apply it anywhere. Okay, it's just in the measure, and I don't think that's what should be. That's not the right thing in the measure, so we got to straighten that out. All right, we're due for a break. We'll take a quick break. I've only got till half past the hour. It's almost 1:10 now, so come back and probably at least get our test together, and maybe start straightening out the fact that we're mixing up time signatures and unit note lengths is very significant. Okay, and it's wrong. All right, so see you in about 3 minutes. All right, hey, welcome back. Okay, so let's try and straighten out this default rhythm. I think that is the time signature, but this is just not right. This is the unit note length, and it should not adjust that. It's a different thing. Var unit note length equals, and I'm going to say we default to 1 1, just kind of multiplying by itself. Okay, and adjust it here equals new unit note length. Okay. Yeah, but these elements need to be modified. And I don't know. This is the trickiness. Like, I don't want to. I want to respect that if the type's not right, it shouldn't do anything. But I want to say if you change one of these, we should be multiplying this by the unit note length. Let's see. So, score. Let's get back to score tests. Where's that test I just started writing? Tune tests. Okay. Let's start with a score test instead. score knows measures. Measures can accumulate rests. Good. Okay. Now we want to say score reflects unit note lengths. Okay. So if we put, let's say we do this. Okay, so ABCD rhythm, let's make it 1 1. Right. Okay, so the rhythm, I don't care. I want the note length. Let's say, let's see, what do we want to do? Well, it's going to be something like this, right? So rests, I'm going to have elements, I'm going to do some score stuff, and I'm going to do this and then make some assertions. That all sounds plausible. Okay. I'll take that out. All right, so the elements, let's put the notes and a bar line, and then let's do notes.reverse. Oh, let's put another element. Okay. So we'll put the notes, we'll put a bar line. So this is the measure. Okay. And then instead of rests, I want to put the notes reversed. But before that, I want to put a unit note length change to rhythm 1/4. Okay. Yeah, that's what I want to do. Okay, let's do it like this. I'm not going to worry about bar lines. That's a distraction. Okay. Let's put 2 rhythm. Gosh. Okay. We'll put one before and one after. Rhythm 1/8, rhythm 1/4. Notes.reversed. That. Okay, and I don't know if I need to put all these in brackets. Oh, I do. And this may be there may be a better way to do this. Okay, I got AB, rhythm 1/1. I put them note length changes in for a 1/8, do the notes, do 1/4, do them backwards, flat map it, and then build a score from that. The result should give me score.measures, and there's only one, so that's fine. But I think I want to say my expected ab.map rhythm 1/8, and then let's call this absolute rhythms, and then our expected is going to be another map. Okay. Okay, so it's going to be absolute rhythms, and I'm going to make 1 and a 2. Okay, I don't know if this is harder to read than I want. Expected absolute rhythms 1, absolute rhythms 2, dot flat map $0. Okay. Boy, that's tough to read. Okay, I'll just say we want this. Okay, there's only one measure. Excuse me. And this should be 1. Okay, measure R44 should be expected. All right, let's go through it again. Okay, so we're going to make AB all be whole notes, and then BA is the reversed, is also going to be whole notes. So it's note length change to 1/8, whole note, note length change to 1/4, whole note, whole note. In the end, it should become eighths, and then these should be quarters. So they should be multiplied by their corresponding note length change. Okay, and so here's the expected AB with eighths, BA with quarters, and the result should be a measure with the rhythm 4/4 and expected. And this is going to fail big time. Good. Okay, what happened? Well, we got whole note, whole note, whole note, whole note, not eighth, quarter, quarter. Okay, so our note length is not being applied at all, which is what we expected. Okay, because we create it and we never reference it. All right, so this updates it to the current one. We default to 1/1, okay. But the measures need to deal with that. Okay, the elements. Now, we need to basically multiply the unit note length times the rhythm of this element. Okay, so let's do that, and I'm gonna do that as a musical element test. Let's just add a test for that one feature. Okay, so ABC parser. No, this is musical element. We don't have tests for it specifically, so let's make musical element tests. Okay. All right. There's, let's see, what's the test we want? I think we basically want to say, given a musical element, I want a function that returns a musical element multiplied by a rhythm. Okay, so let's say note multiplied by rhythm. Okay, and we can almost take the note we did up here. So MusicalElement.note, the note is string, we don't really care too much, B, whatever. B natural with a rhythm of 1/2, let's say. And, all right. And if we say let actual equal note dot multiply, let's say a rhythm, well, let's make this interesting. Multiply a rhythm of 1/8. All right, and then assert, I expect actual dot rhythm to be 3/16. 3/16. So we're just doing, it basically works out to mathematical multiplication of fractions, right? 3/2 times 1/8 is 3/16. I hope I'm doing this right. I think I can be consistent even if I'm not right. All right, and then the musical element. This is a function multiply by a rhythm. And it returns a musical element. I think that should be all right. And then we have to do this stuff. Okay, so if it's note of a value, well, we're going to have to do some tearing apart here. But if it's a default, let's just return it. Okay, so return yourself. And actually, we can let this go to this first too and make this thing fail properly. Okay, this test should fail. Cancel. Should be in both these. Value type musical element has no multiply. Oops, now it changed its mind. No. Actual dot. Okay. Okay, let's take that. The description should be a natural 3/16. Okay, and I'm going to steal a character when I get it. Okay. Oh, right. B natural 4. Is that how they spell it? And then the rhythm. Okay. Yeah. Let's do that again. Okay. Now we're getting 3/2, what we originally put, but we're not doing any multiplying. Okay. Let's see if we can do this. The value is a note. Sorry, let's find note. All right, so rather than pull apart all these things, I think we're going to put a multiply on here as well. Is that going to work? Okay. And it's going to be the same note. So we're going to return note of note name, accidental, octave, key, And rhythm is going to be rhythm dot multiply by. Do I have to say key? I guess I can leave off key. We're going to have some work to do when we get around to keys. Okay. So I can do this if rhythm has a multiply, which it doesn't. Okay, so let's get rid of rhythm and give it a multiply. Okay, and this is just a rhythm of the numerator is the one, self dot numerator times other dot numerator, and self dot denominator times other dot denominator. Okay, so that's the mathematical side of it. Oh, bonk. Multiply produces a rhythm. Okay. And that may result of initializer is unused. Oh, I didn't define a return type there either. Returns a note. Okay, musical element tests. All right. 3/2 is not 3/16. Okay, so we're at a failing test, and I'm out of time today, so we'll pick up there tomorrow. It's the same time. It's 1 to 3:30 p.m. U.S. Eastern Standard Time, or 6 to 8:30 p.m. UTC, and pretty confident we'll get this note multiplication working tomorrow. And once we got that, then we should be able to finish testing our inline length changes and probably move on to parts and key changes and get those things kind of together too. We have more to do, but we'll get that going. All right, thanks for joining, and I hope to catch you again sometime. Take care. Bye-bye.